We'll now look at Rolle's theorem. And Rolle's theorem provides us a set of conditions, and if we can meet those sets of conditions, then that means that there is a number c that is within an interval from a to b to where the derivative of our function with respect to c is equal to 0. And so what does this actually mean? The derivative of the function with respect to c is equal to 0. That means that when we look at the graph of our function, there is a critical point within our interval. So what is a critical point? It basically means that there is an inflection on your graph. So it'll go from a decreasing value to an increasing value. So you can see on our graph, there is a point C where there is an inflection, and that means that the derivative of our function with respect to that value C is equal to 0. And all this is saying is that there is a horizontal tangent line. So we'll go ahead and look at our example problem. F of x is equal to x squared minus 2x minus 8 on the closed interval -1 to 3. And the first step is we want to determine if we can use Rolle's theorem by satisfying these three conditions. So the first condition is easy. We can see that it's continuous from -1 to 3 since there's no skips or breaks on our graph. The next step is we want to know if it's differentiable on our open interval -1 to 3. And basically what that's looking for is just determining if there is any vertical tangent lines. Because if we have a vertical tangent line, then we have an undefined slope. And we can see that there's no vertical tangent lines on our graph. The next step, or our next condition, is we want to verify that f of a, which is -1, is equal to f of b, which is f of 3. And you can see that when we plug -1 into our example problem for x, we get -5. And when we plug in 3 for x, we get -5 as well. So all three of these conditions are satisfied, so we can use Rolle's theorem and solve this. So the first step is finding the derivative of our function, which is 2x minus 2. And using Rolle's theorem, we can say that f prime of c is equal to 0. So we can go ahead and plug that in. So 2c minus 2 is equal to 0. And so we can get c is equal to 1. And the next step is just verifying that our c is within our interval. So from -1 is less than 1, which is our c term, which is less than 3. And you can also see that c is equal to 1 is an inflection point on our graph.